Hello, my name is Brent Lanier, and I'm here to present my final project for CSCI E-63 Big Data Analytics for spring of 2015. I'm here to discuss the Amazon stack using Redshift and S3 to enable real-time analytics in the cloud. So first, let's talk a little bit about the business problem that's facing the enterprise today. Enterprise data is growing at an exponential rate for both structured and unstructured data. In 2012, Oracle released this graph where it said data is growing at a 40% compound annual rate, reaching nearly 45 zettabytes by 2020, which is amazing considering that 2020 is only about 5 years away. As this data is growing, data requirements are changing rapidly for corporations. And as a result, the business agility suffers because its reporting is unable to change with the pace of business. As businesses move to create additional data silos, they begin to create these bottlenecks in reporting where data from one data silo can't map to the data of another data silo. And another major problem with this explosion of data is that the cost to maintain this data has become prohibitive for companies. The hardware is not scalable, and it's incredibly expensive to support for both personnel as well as maintenance of hardware. So one of the solutions that we want to take a look at in this final project is leveraging the cloud, and specifically leveraging a number of services within Amazon Web Services. Amazon over the years has built a very comprehensive offering that's both scalable, flexible, and cost-effective across a variety of computing needs. It first started with the Amazon Compute Cloud, where companies could buy computing resources to run their own Linux or Windows virtual machines. And then they've expanded in other areas like file storage, or Hadoop data processing, or data warehousing, and a variety of other services. So we're going to take a look at them, a bunch of them in a variety of ways, to see how we could use the software as a service or infrastructure as a service type model that Amazon offers to solve not only our data warehousing problems, but how can we make the business agility increase by enabling real-time analytics. So a couple of the services that we're going to take a look at is Amazon Redshift, which is their data warehousing component. We're going to look at S3 on how can we persist files as data moves into Redshift. We're going to look at data pipeline on how we can enable data orchestration and ETL using easy-to-use tool that's already embedded in the Amazon stack. And to round out our simulation, we're going to use Amazon's Elastic Cloud Compute platform along with MySQL to handle some simulated transactional processing. And then finally, we're going to run ClickSense Desktop on our own machine, which is a business intelligence tool that's used widely in the enterprise. So to get started, we're going to talk a little bit about Amazon Redshift. Amazon Redshift is a petabyte scale data warehouse that's optimized to store large amounts of data, using a lot of cutting-edge technologies like columnar storage, data compression, and zone maps. Amazon Redshift can scale across multiple nodes and return very efficient and fast querying for data that can reach up to 2.5 petabytes per cluster. It's incredibly cost efficient. On-demand pricing starts at 25 cents an hour and can run as low as $1,000 per terabyte per year. But the key here is that Redshift is a service that Amazon is delivering. You can get started in minutes by using a web console or the CLI, a command line interface. You can get started with Amazon Redshift and start moving data in almost immediately. It's completely fully managed by Amazon. The back end structure of service, as well as it's fault tolerant by enabling automated backups and fast restores. Your data is encrypted and you can manage your own keys. So it's a highly secure platform for businesses to house their data. And best of all, it's compatible across a variety of different SQL transactional databases, as well as data integrations. It uses industry standard ODBC and JDBC drivers to connect to the Redshift clusters to pull data in, or to extract data out, or to import data in, making it an extremely flexible system for corporations to be able to leverage as an extension of their own on-premise data warehouse solution. S3 is Amazon's simple storage service, and it is their online file or object storage tool. It allows for high durability of files. Your data is redundantly stored across multiple facilities and devices. It has a 99.99% availability that's across multiple AWS regions. And like other services, it's highly securable, scalable, and low cost. You only pay for what you use, and you have flexible capacity based on your data demands as they go up and down. AWS Pipeline is a really interesting data orchestration tool, and we're going to use it as our extract, transform, and load function as we look at data coming out of a transactional system and into the Redshift data warehouse. It's incredibly reliable. It has a distributed infrastructure that ensures activity completion and it can notify you proactively by using the simple notification services of Amazon. It's very simple to use. It has a drag and drop console, has a visual pipeline editor. As you build out your ETL function from your source to your destination systems, it's very simple to see how that data flow is going to look. And if you're using it to integrate different Amazon services, they offer pre-built templates. And like the rest of the Amazon Web Services stack, it's highly scalable and incredibly low cost. Finally, we're going to use the Elastic Compute Cloud running a Linux machine that has MySQL running on top of it to simulate a transactional processing as a part of our demonstration. We're going to simulate a massive data update in a transactional system and the steps that we would go by to see that data in Redshift. And finally, in order to visualize that data change in Redshift, we're going to look at that data through the eyes of a business executive using ClickSense Desktop, which is an industry-leading data visualization and business intelligence tool, giving you drag and drop visualizations, analytics across multiple device types, and really gives you that self-service simplicity. So a quick recap before we start our demonstration. The Amazon Web Services encapsulates the majority of the services that we're going to be using. We're running MySQL in an EC2 Linux instance, and we're going to be using Pipeline to pull that data out of MySQL and put it into Redshift by way of our S3 storage, persistent storage layer. ClickSense Desktop will be used by our business executives viewing their business intelligence reports. Those reports will connect to Redshift to get their data. So let's take a look at the demonstration. We're first going to start in MySQL Workbench. You'll notice down here in the bottom I have a connection going to what is a CNAMED IP, but where it's actually headed to, if we take a look in our EC2 Management Console, we have a T2 micro instance running on the Amazon Web Services. Now this is running a Linux machine that has MySQL running within it. So back in MySQL Workbench, I have a database, E-63 FP data. It has a variety of tables in it, and really we're going to focus on the songs data table. Taking a look at the columns, we can take a look that this is a table that contains descriptive information about songs. And we can take a look at what that data looks like by just doing a simple select statement on it. So let's take a look at the data. So we pull it up, we have titles, we have artist names, we have a bunch of other song IDs, track IDs. Year is over on the is over on the side. If we can make our way over to it, we have year over here. So a variety of data. And as of right now, this table has exactly 515,576 rows within it. So the next thing you want to take a look at, that's how our transactional system looks like. We're going to hop over to SQL Workbench. Now you'll notice the SQL Workbench is connected to Redshift. This is connected to our data warehouse. You can take a look at the elaborate URL that we have connected to Redshift up here. And I've already done a select statement on the one database table that we have in here, but I'll do it again. And you'll notice, I'm pulling back all of the data, which might take a little bit of time, because you'll notice that I have 515,576 rows on here. Now we've created this table which has this similar information up here. In fact, I'm going to stop that because this is going to take way too long. But I can actually just do let me do the select count on it, so you can take a look at what that looks like. But you'll notice up here at the top, we've already done the create table statement on here, where it has the similar title, song ID, release. Oh, and it actually pulled some of it back for me. So we have title, we have release, we have song ID, we have track ID. It has the same amount of data in it that our previous transactional table has, 515,576. And we can actually take a look at what this data looks like through our business intelligence report. So I have a report here created that's connected to my Redshift database. This is a simulation of what a business executive would visualize this data like. We have it by year, the percentage of songs that were released by year, and as I click on each section of the graph, my artist and song titles change depending on the selections that I have created. So to give you a visualization of what this data looks like. So what we're going to do is we're going to hop back over into SQL, MySQL, and we're going to simulate a transactional update. So what I'm going to do is I'm going to add some additional data to my songs database. And I'm inserting into songs data some data from the songs new data. And really what I'm doing is I'm adding a bunch of data with new years. You'll notice that I have 484,424 rows now. Now if I do a count on my songs data, you'll now see that I have 1 million rows. So what I want to do now is I want to take a look at what it would be to migrate that data. So I've brought up my AWS pipeline. You'll notice that I actually have 2 pipelines already created. I have an S3 to Redshift pipeline, and I have a MySQL to S3 pipeline. These were the initial pipelines that populated Redshift the first time. Now the first thing I need to do is come over to my S3 management console. You'll notice that I've created a bucket that I'm going to store my data and logs. And you'll notice that I actually have data in here. So what I want to do is delete that data, because this new pipeline is going to bring new data in. So that's done. So if I go back into pipeline, the easiest way to do this is to kick off a new clone of my pipeline. So the first thing that I want to do is bring my data over, and I'm going to clone this new pipeline. And I'm going to call this update. And I'm going to clone that. What clone does is it brings me into this visual editor. And this is what we talked about before. You'll notice that over here I'm connecting to this JDBC connection. This is my MySQL database. And I'm pulling out the data from the songs data table. And I'm going to store it into that S3 location that I was just in. It gives you a very nice graphical representation of what my ETL process looks like. And I'm going to simply just activate this. And by activating it, it's going to kick it off. And now it says my pipeline is now active. And I can hit refresh. And this will go through a number of different statuses as it goes through. So a couple of things that it does. It waits on dependencies, then it waits for a runner. Waiting for a runner really means that it's bringing up a new EC2 instance, and it's going to run my process on that compute instance and then terminate that instance when this pipeline is done. So we'll wait a couple of minutes until this is done. Okay. It looks like our pipeline has now finished. We can take a look at our execution start and execution end times. It took a little bit about 5 minutes to do the MySQL to S3 extraction. And if we go back into our S3 management console and do a refresh here, what we'll find is we actually have a new time, 5:10 at 5:12. And if you take a look here, we have a 180.5 megabyte file, CSV file, that is waiting for us in our S3 bucket. So this data, our MySQL data, is now persistently stored in our S3 bucket. So the next step that we want to do is we want to go back into pipelines. And we want to pull this data into Redshift. And we have our initial S3 to Redshift job here. So I'm going to clone this pipeline again. And we'll call it update. And it's going to bring up the visual editor again. And we can take a look at what those S3 input node destination Redshift table. We can take a look at what these parameters look like. We can see that we're going into that same Redshift URL that we saw earlier. A couple of different copy options, override existing, and then our input S3 location is that same data. So we're going to go and activate this. And it's going to go through a similar process. It's going to kick off a new EC2 instance that will actually run the pipeline job on those compute resources. So right now it says waiting for runner, which basically means that it's waiting for that EC2 instance to come up. While that's running, let's just take a quick look at what the Redshift cluster looks like. So we have a cluster here. It's called E-63 FP Redshift cluster. This is in the Amazon Redshift web console. We have a healthy DB, a couple of different recent events, but it's a very descriptive information that gives you an idea of what your database looks like, your health, cluster status if you're in maintenance mode, and a variety of other options. You can do snapshotting, you can create reserved nodes, and I found this to be very helpful. This is your Connect Client screen. So this will tell you what your URLs are very quickly instead of you having to figure those out on your own, as well as you can download your JDBC and ODBC drivers with connection information. Very, very helpful on the web console. So if we go back to data pipeline, we'll see that it's still waiting for runner. So this will take a couple more minutes. We'll pause here and come back when the job is completed. Okay, and we're back. And now our S3 to Redshift job has completed. Starting at 1918 and ending at 1922, it took roughly 4 minutes for this job to complete. So all in all, it's about 9 minutes worth of jobs. And keep in mind that since we split the two jobs up separately so we could store our results on S3, the majority of that time was instantiating the EC2 instance. So you could actually combine these jobs into one. It's still store on S2 and really cut that time down. So now that our data is in Redshift, let's hop back over to the SQL Workbench and let's do a count again. And hopefully we have a count of 1,000,000 rows, which is the amount of data that we had in MySQL after we did our transactional update. So the final step of this presentation, or of this demonstration, is to update our ClickSense report. So we'll notice that this is what our report looked like before. Now let's say that I'm a business executive that has this scheduled to update. We're going to have to push a data update. But let's assume that this is an automated process for a business executive. We're going to come in here and we're going to click the Load Data button. And this might take a minute or two to pull down the data, but effectively we're connecting to Redshift and we're pulling down the database and the data contents in its entirety. So let's take a moment and have this finish up. Okay, and our data load has completed. It took about 1 minute and 13 seconds to fetch 1,000,000 rows out of our Redshift cluster. Now I'm also running ClickSense Desktop within a virtual machine on my laptop. This would actually take much less time. I think it only took about 15 or 20 seconds when I ran it on a desktop earlier. So but even at that rate, it's still a very quick process. And if we go back into our report now, we'll notice that our data updates have now changed. So we'll go back over into our main app screen, and then we'll pull up that number of songs released sheet again. And now we have this huge chunk here. 48.4% of our now 1,000,000 song repository has a song year of 0. This was the data that we put in. If we click on that, it'll bring up all of the artists and song titles of that percenter of that particular data function. You can do searches by artist and song title. It's a very, very interesting application. So in recap, let's come back to our presentation. So in recap, we have, in the span of a short 15-minute presentation, we've gone through the process of utilizing a variety of Amazon Web Services tools to really enable real-time analytics. We made a transactional update in our MySQL database using AWS Data Pipeline. We pulled that data out, we persistently stored that data on the Amazon S3 service, and then we pumped it into our Amazon Redshift data warehouse, and then we viewed that data in our ClickSense desktop. Amazon Web Services is a powerful platform to extend on-premise infrastructure to the cloud. It enables massive data consolidation, very efficient and easy to use ETL orchestration and workflow, and it really simplified resource management and drives down computing cost across multiple services. The changing needs of business executives can be made quickly and efficiently by supporting industry standard data source connections. And the main key here for businesses is that existing reporting and dashboardings can consume AWS Redshift data with no code changes to the reports themselves. So the big power, besides cost for these tools, is the ability for businesses to effectively forklift up existing data warehouses and put them in AWS Redshift with very little overhead and minimal effort on their part. Overall, this has been a great project, and I'm really looking forward to analyzing this technology the next time we take a look at a data warehousing or business intelligence initiative in my career. Thank you very much for watching, and I hope you got as much out of this presentation as I did exploring these technologies. Thanks a bunch.